Hi folks, in today's video we're gonna go and review the chicken water system that kind of redesigned from the Carolina Coops design, which used a PVC with some chicken nipples for the water and a pump and a water heater in a bucket and so forth. Today I'm going to go review the design and what exactly the modifications I've made to improve on their design, which was a pretty good design to begin with, but I found that there are some opportunities for improvement, and I did that in this video. So anyway, just for starters, we just want to make sure that I want to make sure that you guys know that this is it's a small scale compared to what they have in Carolina Coops. I only have 8 chickens in there, and there's only really 4 nipples in there, but you can expand this. This will work for more than just 4 nipples. You can just have a longer PVC or add more nipples in there if you want. So anyway, so the design is as follows. So you have the bucket, and this is a small scale. I ordered a bigger one, and it's not here yet. So we're gonna attach this for now, just for the purposes of this demonstration. We're using a smaller bucket. This will be the water source. Now this could be the same water source as your bigger bucket that catches the rain from the coop, but since my coop is really small, it doesn't make any sense to see. It's not a very big coop at all. There's not a whole lot of water that can be captured from there, so I'm replacing this with a bigger, I think 40-gallon one. You could use a 55-gallon one as well. And obviously, it all depends on the space that you have. As you can see, that my space here is not very big. I don't really have a good space for my coop and for this water system in the place where I have it. So anyway, so we have a spigot just like Carolina Coops. I ordered all of these things. By the way, all these things that I will show you are I just got them, I think, if not all of them, from Amazon, probably with the exception of the PVC pipe itself, the 2-inch, which I picked up from Lowe's or Home Depot. Anyway, so you have a spigot here, which is your standard hose bib attachment. That's an adapter. This thing, we picked it up from Amazon as well, and you have a valve that turns on and off. This is just a bucket, so you can replace this with any kind of drum that you choose. The drum we're getting already has its own spigot and adapter for the hose, so I just don't have it yet. I will make an updated video once it arrives, and show you guys how the finished product. So for now, you notice that there's water that's coming right back in. It's recirculating, and that water is really being recirculated through the pumps that through these lines right here that you see. There's the pump right there. So the water comes in from the bucket, gravity fed. That's the one key factor here, is it has to be your bucket or your water source needs to be higher than your feeder tube, right? Just so the water pressure will go right in, and I also chose to use this metal hose that allows it to to be a little tougher in case you can roll on it and step on it, and the chickens won't be able to damage it in case they peck at it and everything. And as you can see, Sorry for the camera angles here. So that goes into another adapter, which is another hose bib adapter there, as you can see. And then that hose bib adapter is a 3/4 to a reducer that is inside. And you can see a PVC T adapter. This is a 2-inch pipe right here, as you can see. That's a 2-inch pipe, and this is a coupler with a T, so that I can turn this on. And so when I fill up the water, but I don't fill it up through here. This is basically your overflow to get the air out of the system. So the Carolina Coops video, they pretty much had the pump right before the PVC as part of the intake. So it's pumping the water into the bigger PVC, and then it goes back out. Goes back out to the other side and back into the pump, but back into the bucket. However, in my thought, that if you had air in the PVC, they mentioned that it had to be, you had to set it up to where the PVC, the pump was on the lower end. So as it comes in, it's lower on the intake and higher on the return. That's not the design that I opted for. Instead, I chose to use gravity to my benefit, meaning because you want the air out of the system, you want the water to be able to push the air out without too much effort coming from the pump. So the pump is the whole purpose of the pump is just to return the water, as you can see, it's just to return that water back into the bucket. So your pump isn't going to work as hard, and probably, in my opinion, will last a lot longer than having to push all that water coming all the way from this PVC in the intake, because it widens and you lose pressure in the process as well. However, if you tilt it where the intake is higher and where it feeds back in is lower, then the water will naturally flow down there, and you just need a way for the air to go out of the system. And that's why I built this T right here, and I put a valve so that if I want the air out of the system, in case first time I'm refilling it, I can just open this valve and it'll flush out all the excess air that's in the system. Now, if there's no air in the system, and obviously you can do this as well if you want to do this with an actual hose with a stronger pressure. So right now the pressure isn't strong enough. So, but you notice that there's no water coming in because it's just cycling right through. All right, it's right through there. So in actuality, I don't really even mind that there is a little bit of water in the system, because it's going to still flow down and it's not going to get impeded. All the water is still flowing down, and as you can see down here, I put in a clean out. So if I ever needed to clean this out, I can attach a hose bib in here, right? Which I have an extra one. I could probably 3/4. This is 3/4, and to a hose bib, and flush this out and clean it out, and just open this, and all the water comes out there, and it goes right out the coop. This is a French drain that I created, that I put all the way across my back fence here, and then that goes into actually this is a deep well here, a dry well that's several feet deep. So anyway, having said that, these this is also another T, right, which has a clean out, and this is a PVC reducer from a 2-inch to a 3/4, and the 3/4 goes into a hose, a 3/8 of a hose, I believe is what it is. It's the measurements. I'll have to double check that. But anyway, and then it just returns straight in here. And this is all gravity fed. So so long as it's higher on this side, all this line will be filled with water. This thing doesn't have to be going lower all the whole time. You just need to have that lower, because your bucket is higher. It's still going to push that water all the way down that hose, and once it hits this pump, it'll just push the water back up, and as the pump keeps sucking the water through, it'll just go straight back into the bucket. Now, the other thing is, okay, so that's well and good for water flow, but when you're talking about winter, so obviously you need a heated water so that to keep your pipes from freezing, and so water flow is key, but water temperature is also key. So what Carolina Coop's video has this is, I didn't change anything here. This is a thermostat adapter, or thermostat plug rather, and this one turns on, I believe, I think I read the specs. It turns on at about 45 degrees or something like that. So it senses the temperature outside, and then I plugged in here this is only a 500 watt water heater. Obviously, you can buy another a higher voltage one once you have a bigger one. I only have a 40-gallon one that I will put in here, but if you have 55 gallons, then you can probably up it to 1,000-watt water heater, or de-icer, I believe is what it's called. And then this is a self-regulating one as well. So it's key to have a self-regulating one, as the video in Carolina Coop said that you want to. Okay, so I had to retake this video because my phone ran out of battery, and so anyway, as I was saying earlier, we're using a de-icer, 500 watts, self-regulating, so that it can maintain the temperature and not get too hot. We also have this this plug that turns on at a certain temperature as well. So with both of them, you covered on both sides, whether or not it's cold outside, too cold outside, and your water never gets too hot, right? So that's the purpose of that. This is just a I believe a 14 gauge wire. I did some calculation, and that should be sufficient for a 500 watts. But if you're using 1,000 watts or 1,500, probably would want at least a 12 gauge, or preferably maybe even a 10 gauge extension wire, extension cord, so that it will you won't end up having your not your wire too thin, and not being able to carry enough load. The other thing I also want to point out was from a pressure perspective, right? So I was talking about earlier that this I noticed when I turned it on, no water came out, right? But the only reason why there's no water coming out of there is because the water is moving down the pipe. But rest assured that that pipe is filled with water right now, and because it's gravity fed, and because it's going narrower, it's going to fill that pipe first, and because the intake is also thicker, it's a garden hose, and this is just a 3/8 line. So it will fill up faster than it could empty out the other side. Okay, and to prove that, I'm going to go and turn off the pump here. I'm going to unplug this pump. I can do this with one hand. Do this real time. Okay, I just unplugged the pump, and notice water keeps coming out of there now, right? All of a sudden that came out, and that tells you that there's that whole tube is filled with water, and now it's actually filled all the way here. The only reason why the water wasn't coming out was because the pump was feeding it through. But the moment I disconnected that pump, that water started coming out of there. So you will never have a chance of having air on the line. And you know, one of the problems that they were talking about, because your pump is pretty much just moving the water, and you're using gravity to feed it, and because you have narrower returns than the intake, then by virtue you're going to end up filling that pipe a lot sooner. And they noticed the water dripping in here. Now they're all trying to drink. Anyway, so that's pretty much the gist of it. I'm going to try to plug this back in and turn it back on. See if I can do this in one hand. I don't think I can. Anyway, that's probably the only thing I have for the video here today. So hope you guys enjoyed this video, and hope it helps others. And I will post another one as soon as I get my bucket. Okay, now I just turned on the pump. As you guys can hear it. All right. By the way, these are hose clamps. So I separated it, the pump specifically with hose clamps like these. I could have probably attached this pump directly into the, because these are 3/4 inch adapters as well. I could have probably posted this. I mean, put it right outside on the other side of the PVC over there in the return. However, I wanted easy maintenance. In case the pump goes bad, I can easily take these hose clamps off. I can easily take these off. If I can replace the hose clamp easily, and I can easily replace the hose, I mean the pump itself as well. It's ease of maintenance. So obviously I got excess line here. I will cut that off once I get the new bucket. And I have some additional improvements that I have in mind, but for now, that's all we have. And I will make additional videos. And that is Charlie, and he likes to catch. There he is. Good boy.